Oh goodness, hey geometry. It is absolutely no fun just teaching to a computer. So I'm trying to imagine that I'm teaching to you all right now. So thanks for doing this and tough it out and take really good notes. We can do this. I think 6-2 and 6-3, I think I would rather do with you all in person, so I'm going to hold off on those. Let's go ahead and jump into 6-4. And let's do a review before we go to 6-4, but that's the goal. So right now, you can pause me to do these, but go ahead and find the perimeter in the area of this rectangle. Again, you can see opposite sides are congruent to each other, and we've got 4 right angles. So don't forget, perimeter is going to be 2 times the length plus 2 times the width. Or 2 times the base plus 2 times the height, or just add up all the way around. Okay, no biggies. And don't forget, area of a perimeter is going to be the base times the height. So jump on that. For the parallelogram, same thing really as the rectangle, just do base times height. And finally, to get you started off on this well, find the value of x for this right triangle. Okay, the side got a little wonky there, but that's supposed to be straight and it's supposed to be 12. This side is x, that's the side you're solving for. And hint, hint, your hypotenuse, the side opposite the right angle, is 20. So hopefully you're remembering the Pythagorean theorem for this. A squared plus b squared equals c squared. Okay, if you haven't paused me yet, go ahead and start on those. Okay, so now let's check and see how well you did. 2 times the length for the perimeter, which is all the way around, is going to be 2 times 13 feet plus 2 times a width of 6 feet. So 2 times 13 feet is 26 feet plus 2 times 6 is 12 feet. Add those together, you get what? 38 feet for your perimeter. So if you got that, give yourself a check mark and nice job. And for the area, because we're asking you to find both, the area is base times height. So your base is 13 feet. Your height is 6 feet. Go ahead and multiply those together. 6 times 3 is 18. Carry the 1. 6 times 1 is 6 plus 1 is 78. So if you got an area of 78 feet squared, you're correct. Give yourself a check on that. Okay, so there's that. Just again, don't forget everything we've learned. You don't know where this might come in handy. For the parallelogram, your base is 9 inches. And I bet you recognized, hey, there's my height of 10 inches. Remember, that's got to be perpendicular to that opposite side. So height is 10 inches. So if you did 9 inches times 10 inches and got 90 square inches, you are correct. Give yourself a check mark. Okay, last one. I already gave you the Pythagorean theorem. So the main thing is putting things in properly. So for a squared, you can say that's 12 because it's just a leg, plus the other leg of this right triangle is an x. So we'll put x in for b. It's now x squared. And c squared, that is your hypotenuse. So it's opposite the right angle. That's going to be 20 squared. Okay, so now just be careful. 12 squared is 144. 20 squared is 20 times 20, so that's 400. Subtract 144 on both sides. I want to make sure I don't mess this up. Though I think it's going to be what? 256? Yeah, I was going to be off a little bit. So subtract 144 on both sides, you get 256. And notice x is squared. So the opposite to solve is square root, square root. So if you get x equals square root of 256, if I'm correct, that's 16. Yeah. So this side right here is 16. Okay, so good job. I hope you got all those. Don't forget to always try those and write those down. Okay, now let's get into this. 6-4, officially starting. This is going to be volumes of prisms and cylinders. That's the title of this one, Volumes of Prisms and Cylinders. So, I think you all remember this, but let's go ahead and make sure. Volume is the space a figure occupies. And it's measured in cubic units. Because again, it's three-dimensional. So for like this figure, you know, how much does it hold? We're not talking about surface area. We'll get into that later. But if we pop this top off, and well, okay, there we go. How much three-dimensionally does this hold? So like all the way up to the top, how much does it hold? That's the volume. We're finding the volume. Okay, so we'll just start with this. Volume of a cube. And you know a cube is like a box that's equal on all its sides. So let's go ahead and start trying to draw these figures. We need lots of 3D figures. So a cube would be, for example, if you have 5 inches for the height, 5 inches for the width, and 5 inches for the length. It's just equal all the way around. The volume of that is just going to be an edge, which would be here, or an edge here, or an edge here. Just pick an edge and it's going to be cubed. Okay, that's how you find that volume. So in this case, let's go ahead and do that example in case it comes up. The volume of this little box would be an edge being 5 inches. We're just going to cube that. So 5 cubed, here's a reminder, this is going to be 5 inches times 5 inches times 5 inches. Okay. And so 5 times 5 is 25. 25 times 5 is 125. And inches times inches times inches is inches cubed. So just a reminder there, anytime we're doing volume, it's going to wind up being in cubic units. I need to see units cubed or whatever. Okay, so there's that. Okay, let's go ahead and do a prism. Let's do a prism problem. Just a reminder on these, let me turn to the right page. It's going to be the volume of a prism is going to be the area of the base times the height. So it'll look like this, BH. Know that that capital B is area of the base of the prism. And know that H is going to be the height. Okay, so I will remind you all of this. A prism is a I misspelled that. A polyhedron. A polyhedron with, here you can use some shorthand if you want to. A polyhedron with 2 congruent, remember the equal sign with the little squiggly mark above it, 2 congruent parallel bases, okay? So this is an example of a prism. Okay, sorry, I'm pulling out all my health stuff. Notice that we have this base and this base. They are parallel. Hold on, I'm trying to get this. They are parallel to each other and they are both congruent to each other. Okay, so that's a prism. Again, these are the faces, but these are the bases. The top and the bottom that match each other are the bases. Okay, so let's just, for kind of your notes, let's just go ahead and try to do that. I'm going to draw my little T box right here. So put like parallelogram and then draw 3 parallel lines, sides, and then connect at the bottom and go up, okay? And then if you really want to make it three-dimensional, come down a little bit with dotted lines. That's about equal to that third line side that you drop down. Bring it over and bring this out to the front. Okay, hopefully that kind of looks like a T-box, but that's an example of a prism. Notice those two congruent parallel bases on top and bottom. So, tell you what, I will draw arrows to help. So there's your prism, and now let's start doing some of these problems. Okay, so for example 1, you'll have some like this, and I'm going to go ahead and draw this. Just go ahead and get used to getting more comfortable with this stuff. Okay, so there's going to be the top of our prism, and then draw several segments, short segments down like this, and then go ahead and connect across the bottom and connect over here on the side. Now this almost looks like a shoebox, but it still classifies as a prism. There's the top, and then let's try to kind of see the bottom. So let's do a segment that kind of matches this one, only make it dotted. There. And then we'll connect it to that back side, and then go ahead and again, dotted lines going toward this front bottom left vertex. So again, not perfect, but I think you can see that it is a prism. There's the top, there's the bottom. There's your bases. So they tell us, okay, this front part is 20 centimeters across. We have a height of 10 centimeters. And then this side right here, again, thinking shoebox, this is going to be 24 centimeters. And they ask us for the volume. Okay, so let's remember our formula. The volume of a prism is the area of the base times the height. So you can plug it in all at once, or you can break it down and do it separate. But the base, again, think this right here. So for this rectangle, it's going to be base times height, or length times width. It's going to be 20 times 24. Okay, and then we know our height is 10. And I'm kind of running out of room, but you could put centimeters here, centimeters here, centimeters here, and clearly you're going to get centimeters cubed. But 20 times 24 is 480. And then 480 times 10 is going to be 4,800. And imagining your centimeters cubed. Okay, so if you put the centimeters in, I'm fine. If you don't, just remember to tag them on at the end. So there you go. That's all you have to put for that. Aren't these nice? Okay, now let's keep going because they're not all going to be that easy. Okay, so here is B. Okay, remember, y'all can handle anything that's thrown at you. Let's make this prism more interesting. Let's do. I'm going to try to. Okay. Connect. So right now, like a long rectangle. But then let's go ahead and bring this out. I'm trying to make it to where all these sides of this triangle are congruent, okay? And then come back here, and since we're looking at this three-dimensionally, try to do something that matches. And y'all, you know it's okay if it's not perfect, because I never make these perfect. And once you get that triangle drawn in, try to do some dotted spots there, and then connect again with dots going down the back. So I don't know if you think that looks like okay, I'll tell you what, think about Toblerone we were talking about in class the other day. Think about that shape if this is not looking good. Imagine that I've been able to bring those into you, and that's what this looks like. That's the shape. Here are our matching bases. Okay, so maybe that will clear it up. So this is 8 meters. This is huge, but you get the shape. No, you know what? Let's do 8 inches. I want y'all to still be thinking about that candy bar size, and this is a little bit closer. So 8 inches, 8 inches, and 8 inches. So knowing that these match, that you know this is a what kind of triangle? If this is 8 inches, this is 8 inches, and that is 8 inches. Yeah, this is going to be equilateral. So that's going to come in handy. And then notice this is 24 inches. Go ahead and get that in your notes. And you guessed it, they want you to find the volume again. So volume of a prism is area of the base times the height again. Okay, so notice for our base, we have a triangle. Okay, so this base then being a triangle, and we've got to find the area of it, is going to be 1/2 the base times the height. I don't know what the height of that is. Do y'all see that? We've got a base of 8 inches, but we don't know the height. So let's take a minute and go back to some of the stuff you've learned in the past. Yay. Okay. Here's our 8 inches. Pretend this is isosceles. Okay. I butched it up again. Botched it up again. I don't want to butch up anything. But there. Pretend it's isosceles because I got it a little bit wonky. And then let's drop a perpendicular because we need that height, the altitude. Remember this is 8. Remember this is 8. Because it's equilateral. And if you've got 180 degrees and you know all the angles are the same in an equilateral, equiangular triangle, divide by 3. Just a reminder, you get 60 degrees each. Okay, so this is 60, this is 60, and 60 cut in 2 is going to create 2 30-angle ones. Okay, I really hope you can see this. Okay, so this is 30. So as an equilateral triangle, if this is 8 inches and it's cut in half, I think you all realize this is 4, right? So 4 is opposite. Notice we've got a 30, 60, 90, 30, 60, 90. And it's opposite, the 4 is opposite the 30. So quick reminder, I'm going to come up here. Remember, if you've got a 30, 60, 90, and the side opposite 30 is X, to get the longer side opposite 60, it's going to be times square root of 3. So going from the short side to the long side, you multiply by square root of 3. Okay? And while we're at it, let's review. Going from the short side to the hypotenuse, you multiply by 2. So this is 2x. Whatever x is, just multiply it by 2. Okay, so if this short side is 4, then the side opposite 60 multiplied by square root of 3 is 4 square root of 3. Okay, so now we have our height. It's 4 square root of 3. Okay, so yeah, let's just go ahead. The volume of this prism then is going to be, for the base, 1/2. Your base is 8. Your whole base is 8. And the height of this is 4 square root of 3. Okay, now that is just finding the area of this triangular base. This fits the area of this right here. Okay, so that's B, area of the base, times your height of this 3D prism is 24 inches. So 24 should go right there. Okay, now it's math time. We get some more in here. 1/2 of 8 is 4, and 4 times 4, that's going to give us 16 square root of 3 times 24. And I'm going to do my calculator for that. 16 times 24 gives us 384 square root of 3 inches cubed. So that is your exact answer. Okay, but remember, if they ask for it to the nearest tenth or for whatever, let's go ahead and do 384 square root of 3. Hit enter. And so this is approximately 665.1 cubic inches. So just depends on how they want the answer, but those are both right. Okay, good job. Y'all got this. Okay, so again, keep reviewing, keep studying those things. Don't let these things slip because they keep coming back. Okay, next one. This one, easy, but I just don't want you to be caught off guard. Go ahead and draw this parallelogram. Okay, just like that, parallelogram. And go ahead. Let's make it a little bit off. Wait, 1, 2, 3, 4, 5, 6. Okay. So down here, I'm going to do 1, 2, 3, 4, 5, 6. Okay, I messed this one up. Try again. Take 2. Okay, another parallelogram. I'm gonna see if I can do this. I don't know if I'm doing any better at this. I do not understand how I did this before. Take 3. I'm driving myself crazy. Okay, here we go. I'm telling you, this is killing me trying to do this. Without talking to a class. It's so much harder than you can imagine. I'm No, I can't. No, I can't. Okay. I'm still not happy with this. Okay. Good night. I've never had so much trouble drawing anything three-dimensional in my life. This was awful. Okay, and it still looks terrible, but bear with me. The whole point that I'm trying to make here is I'm trying to make this look like my little tea box got shoved over, okay? It's leaning. So, you can't go by the height. The height's not one of these sides because it's being pushed over. So if you get one of those, remember to look for from a vertex to the opposite side, you need that altitude, okay? It's got to be a 90-degree angle. So in that case, pretend, yeah, 11 inches is going to be our height in this case. So even if you see, hey, this side is 12 inches, it's not perpendicular to the opposite side, so you actually can't use that one, okay? But on this, on the base here, let me kind of fill that in. We've got, this is 10 inches, pretend this is 5 inches, okay? 10 and 5. And now we can do this problem. So to find the volume of this box that's leaning over, this prism, remember again, it's the area of the base times the height, okay? So area of the base, look at this. You've got a square, or even if it's a parallelogram, it's base times height, little b times height here. So it's going to be 10 times 5, or think length times width, 10 times 5. And then your height of the prism is going to be 11 inches. So that is what goes in there. Okay. And again, that's 10 inches. That's 5 inches. We're going to have inches times inches times inches for inches cubed. And let's go ahead and do this. 10 times 5 is 50. 50 times 11 is going to be 550 inches cubed for our final volume. Okay, so I'm so sorry about the fact that I could not draw that stinking thing. Let's move on. Okay, so we've done the prisms, three-dimensional with two bases that are congruent. Now let's move on to cylinders, okay? Notice again, we've got a base and a base that match. They are congruent, but then this is circular all the way around. Y'all know what a cylinder looks like. Let's go ahead and label this. The volume of a cylinder is, guess what? The area of the base times the height. If that's bugging you though, because again, remember your base now on a cylinder is going to be circular. Okay, remember that radius. Remember all the way across is a diameter. To find the area of a circle is going to be pi r squared. Okay, so if you don't want to remember base times height, just remember that to find the area of a circular base, it's going to be pi r squared times the height. So you can write it like this, or you can write it like this, because essentially your base is pi r squared for a cylinder. Okay, let's go ahead and do some of those. For switching, these are going to show up in your workbook under example 2. Okay, so go ahead. We'll get used to drawing these things too. Do like an oval here and then part of an oval here, but then fill in the rest with dots and then connect those. And hopefully that kind of looks like a cylinder. For this one, your height is 10 centimeters because again, it's like your cylinder has been laid over on its side. Okay, still the base, but just laid over. And then we've got, this is 5 centimeters right there. Okay, so let's go ahead and find the volume of this cylinder. Let's do the area of the base is pi r squared. So our radius is 5 centimeters. Pi r squared now times the height, which is in this case 10 centimeters. Okay, so let's go ahead and keep cleaning that up. Pi times 5 squared is 25. Centimeters squared is centimeters squared. And then don't forget your height, which is 10 centimeters. Okay, so 25 times 10 is 250. Don't forget the pi. And then centimeter squared times centimeter is centimeters cubed. So that's one way you could do it. If they ask for to the 10th place, don't forget to put that in. 250 pi gives us approximately 785.4 cubic centimeters. So just whichever one they ask for. Let's say that was A, by the way, because I've got another one. Hopefully that's not too bad. Let's go ahead and do example 2B. And it's going to look like this. Go ahead and do oval on the top. We know it's a circle, but again, we're trying to draw these three-dimensionally. And then do kind of a matching partial on the bottom, but then finish it out with dots and then connect. And hopefully that kind of looks like a three-dimensional cylinder. So this time, notice they give you the diameter, which is 4 meters, and they have H for the height, and they tell you that the volume of the cylinder is 12 pi meters cubed, and they want you to solve for H, okay? Don't freak out. It's a little bit different than what you've been doing, but it's not a problem. You all know that the volume of a cylinder or a prism is area of the base times the height, okay? So we know the volume of this is 12 pi meters cubed. The base. Let's find the area of this base. Now be careful. When I first looked at this, I was going to put in 4. Well, okay, let me back up. Reminder, the area of the circular base is pi r squared. Okay, so we know this is going to be pi times the radius is 2 pi r squared, so that radius must be squared. So now we've got the area of the base set up. Times your height, we don't know. That's the unknown, so that's h. Okay, these are all being multiplied together, but think about order of operations on this right-hand side. Do we multiply first, all of this, or do we do exponents first? And if you're remembering PEMDAS, parentheses or grouping symbols, you've got to clean up inside those first. 2 times m, can't do anything but 2m. Then you move on to exponents. We do have an exponent, so we've got to do that first. So let's go ahead and just carry this down. 2m squared is going to be 4m squared because 2 squared is 4 and m squared is m squared times h. Okay, so now in solving for h, these are all being multiplied together. So in order to solve for h, we've got to divide by all this stuff. So on both sides, divide by 4 pi m squared, 4 pi m squared. Okay, same thing. I know I said it in a different order, but remember, multiplication is commutative. 2 times 3 is the same thing as 3 times 2. Okay, so even though I wrote those in slightly different orders, they're the same thing. Okay, on the right, these cancel out. So you're left with h. And on the left, 12 divided by 4 is 3. Your pi, the pi's cancel out. And m cubed divided by m squared, you're just left with m. Okay, so it's 3 meters. And if that doesn't make sense, real quick, meters cubed is m times m times m. M squared is m times m. So notice 2 sets divide out, you're just left with meters. Okay. Or if you remember your rules of exponents, when you're dividing powers, you subtract the exponents. But we'll actually maybe get into that more of that, but that's definitely an Algebra 1 and Algebra 2 concept. Okay, so the height is 3 meters. So that is how you handle it if you're given the volume and you've got to solve for one of these. Okay, you can do it. Okay, I'm gonna give you one of these. Okay, because maybe I'm going to give you 2 more, okay? Because I want you to be able to handle some challenging problems if they come up. Let's say, yeah, let's do this one. Cylinder is cut out. Find the volume of the remaining figure, okay? So imagine, okay, we've got the cylinder, okay, but they have used a machine to cut the inner part of it out, okay? So this is all still solid, but this part has been hollowed out, okay? And we've got to find the volume of basically what's left. So here's some measurements that are going to help us. The height is 5 centimeters. The part that's been cut out has a diameter of 2 centimeters, okay? And then this outer part, the diameter is 6 centimeters. Not 6 meters, 6 centimeters. 6. If you can't see it because my focus is not working very well. So let's go ahead and do it. We're going to do the volume of the cylinder, the whole thing, and we're going to subtract out the volume of the removed cylinder, right? Because it's also in the shape of a cylinder. Okay, let me get a marker that works. Okay, so remember for both of these, it's going to be base times height minus area of the base times the height. But since these are circular bases, you may want to go ahead and think area of that base is pi r squared times h minus, again, whatever this one is pi r squared times h. Now, we're going to start with the bigger cylinder that's actually still here, okay? So it's going to be pi times, now be careful, this is your diameter. We need the radius squared, so half of that is going to be 3 centimeters squared times the height, 5 centimeters. Okay, minus. Well, let's go ahead and clean that up. 3 centimeters squared is going to be 9 centimeters squared, I've still got pi over here, times the 5 centimeters. Okay, and then 9 times the 5 is 45. Don't forget the pi, and centimeters squared times centimeters is centimeters cubed. Okay, that's pretty good. Now let's work on the cylinder that got removed, okay? So it's pi times, you're probably thinking the radius is 2. At first I wanted to do that. But remember, half, this is a diameter, so half of 2 is 1. So this is 1 centimeter. Our radius is being squared, and our height is 5 centimeters. Okay, so 1 squared is 1. 1 times 5 is 5. Don't forget times the pi, and this is centimeters squared times centimeters for centimeters cubed. Okay, so we have 45 pi centimeters cubed minus 5 pi centimeters, oops, that's supposed to be cubed, equals, let's go over here. Think of this like terms. 45 pi minus 5 pi is 40 pi centimeters cubed, okay? And if you put that in your calculator, I mean, that is lovely, but that's also approximately 125.7 centimeters cubed. So either one of those is correct. So even if you see something like this, now mind you, you may have a prism and you'll have to figure out the area of the base minus that circular, the cylinder that's cut out. But you all can do it. Just set it up and give it a shot. For the prisms, for the cylinders, it's area of the base times the height. You can do it. Okay. Here's your homework. For Monday, hopefully you're watching this on Monday or sooner. Practice 6-4 in your workbook. Do the example numbers 1 to 15 all, okay? Show your work. As always, if you just have an answer, you're not going to get full credit. Show your work and prove to me you can do this because I know how smart all of you all are. And then for Tuesday, okay, if you do these and give these your best, then you should be able to like take a couple of curveballs for Tuesday. So think through them, okay? Page 327, do numbers 1 through 9, 13, 15. Oh, I know, sorry. Do 15 through 23 odd, and then do 27 to 31 odd. Okay, now if I can pull this off, I'm gonna actually do these and send out a separate video so you all can see them, or at least send out maybe a picture. where I've got them all worked out so you can check yourselves, okay? But either way, please, please, please do your best. There you go. That will cover Monday and Tuesday, and we'll figure out about Wednesday as soon as I can. You all have a blessed day. Bye.